Hi there, welcome to this video lesson on composition of functions. This is lesson 4 in Unit 1C, and we are going to talk about how we can evaluate a composition and how we can compose two functions. You'll be successful if you can perform a composition of two functions using tables, graphs, and analytical functions, and specifically a mixture of the two, as well as determine a domain of a composed function and decompose a function into two functions. So let's talk about what a composition is. A composition of two functions is when the range of a second function or the inner function becomes the domain of the first function or the outside function. The composition of two functions, f of x and g of x, can be written in two ways. And there's two types of notations, and generally the AP exam will give you both of these in an equivalency statement. They'll say this is equal to this. But both of these read f of, so this little o right here, we say of f of g of x, right? The parentheses are also of x. And so I feel like number 2 is more intuitive, f of g of x. And the way we go ahead and evaluate this is we start on the inside. So I plug in x, and I'm going to plug it into the inside function. And so you can kind of see here, I'm going to plug the x value into g, and the range, what I get out, my y values, whatever gets kicked out, is going to then become the domain or the input of f. Okay, so I'll then go ahead and plug that in. And so we'll do some examples here, which will make it, pretty intuitive. So here we go. Practice problem. The functions f and g are shown. Find g of f of 2. So it's very important. I'm going to start here with this x value 2, and I'm plugging it in to f. So I go to f first, and x2 is my x value. So right here, and I'm going to go down to my function value, and I get this output, which is negative 1. So this is now equal to g of negative 1. So I replace this f of 2 with the output, right, which was negative 1. And now I have to evaluate g of negative 1. So that range, whatever I got out, is now the input for g. And so I go to g, negative 1 is right here, and it looks like my output is 3. So answer there is 3. Start on the inside, evaluate the inside function, and then take that answer, you plug that into the outside function. Here's a practice problem. Please go ahead, pause me, try this practice problem. Find f of g of 1. Okay, so here we kind of reversed it, right? You're supposed to find g of 1. My 1 input gives me an output of 3. So this is equal to f of 3. And then we go to 3 on our graph for f, and that output is negative 3. Okay, and that is it. That's composition. Okay, let's go ahead and see another way that the AP exam will generate this. They'll usually give you two functions, f or g, and again, it can be like an algebraic function, it could be a graph or a table, but they'll define those two functions, and then they'll say there's a function h, which h is f of g of x. It's a composition, and they say find h of 0. Okay, so no problem. H of 0 is going to be equal to f of g of 0, and we do the exact same thing. Okay, they're just adding a little wrinkle where you just have to plug in 0. You replace x with 0. So let's go to g. Let's find 0. Looks like it's 4. If I go up, I'm going to get 4. So f of 4. And 4 for f is going to be negative 5. Not too hard. Try this practice problem. Please pause me, and then I'll go over the answer here. Okay, hopefully you got 4. If you plug in negative 3 into f, you get 0, and then g of 0 is 4. That's it. Okay, let's go ahead and let's see some same type of questions, except this time we have a table of values. And notice this tabular representation involves both functions, f and g. You have input values of x, this is where you always start, and then here are the output values for these two functions, the y values for f, the y value for g. So they say let h be the function defined by h of x, which is f of g of x. What is h of 0? Okay, so I'm doing the same thing. H of 0 is going to be equal to f of g of 0. And I'm going to go ahead and I first need to find g of 0. Remember, this 0 is an x value, so I'm right here, and I want the output of g, which returns 4. So this is now f of 4. Okay, now this 4 is my x value. So now I go to the x value 4, which is right here, and I want f. What's f of 4? 2. Answer is 2. There you go. Okay, plug in the value, start on the inside, evaluate the table, okay, and then take your answer, plug it back into the outside function. Example 2, what is the value of h of 3? H of 3 is going to be f of g of 3. And so I'm going to go to my x value 3. I want g, which gives me 1. So this is f of 1. And then I want the f value at 1, which is 3. Answer is 3. There you go. That is it. Go ahead, pause me. Please try these 2 practice problems, and I'll show you the answer. Okay, here are the 2 solutions. H of 2 gave you 1. When you plug in 2 for g, you get an output of 0. So f of 0, I go to 0, and I find the f value, which is 1. Answer is 1. H of 5, f of g of 5. G of 5 gives us 3. I go to 5, get the g value, which is 3. Then I want f of 3. So I go to the x value, that's 3, and the f value is 4. Answer is 4. Okay, there you go. All right, now let's go ahead. Let's talk about composing 2 functions within each other. Example, the functions f and g are given by f of x equals 2x squared plus 3x and g of x equals x plus 3. Find the expression for f of g of x in simplified form. So I have f of g of x. And what I'm going to go ahead and do here is I'm going to replace g of x. I'm going to replace g of x with what g of x is. G of x is x plus 3. So I just go ahead and I replace that. And then I'm going to plug this in, right? This is now my input into f. So f is 2 times x squared plus 3 times x. And you'll notice I left parentheses because instead of x, right, it's not f of x, it's f of x plus 3. I'm going to replace this with x plus 3. So I just drop this in wherever there is an x, and I just use parentheses to kind of help out with that. So if you're struggling with this, on your outside function, just put parentheses wherever there's an x, and that's what you're going to plug in that function into. Okay, they do want this simplified, so we need to go ahead and expand this. This is 2 times x plus 3 times x plus 3 plus 3x plus 9. I just went ahead and I distributed. And so we can multiply these 2 binomials to give us x squared plus 6x plus 9. And we'll distribute this 2 to give us 2x squared plus 12x plus 18. And then I'm going to combine some like terms here. So final answer, 2x squared plus 15x plus 27. There you go. That is f plus g of x. Okay? All right. Practice problem coming up. I want you to pause me and I want you to try this. And so to start, I'm going to pop back in and I'll show you really kind of like here without the simplification, just composing f of g of x. And then we'll pause again for the composition, okay? Or the simplification. So pause me now, go ahead, find an expression for f of g of x. Okay, here is hopefully what you got if you embedded g of x into f. You would get f of 3x minus 2, and when we do this, we get 3x minus 2 squared minus 6 times 3x minus 2 plus 1. Did you get it? Hopefully you did. Go ahead, please pause me now. I want you to simplify this, so I'll show you the simplified answer here in a second. Okay, final simplification, 9x squared minus 30x plus 17. We'll expand the binomial, so you can go ahead and multiply this out. 9x squared minus the 12x, right? 3x times negative 2 times 3x, that gives you negative 6x with a negative 6x to give you negative 12x. Negative 2 times negative 2 gives us positive 4. We distribute that negative 6 to give us negative 18x plus 12, and then we have that plus 1. So combine your linear terms to give you negative 30x, combine your constant terms 4, 12, and 1, give you 16 and then 17. Okay, another practice or example here where we are asked to find the expression for f of g of x in simplified form. And this one's kind of fun because it involves a rational function. And so what I'm going to do is I'm going to take g, which g is 2x over x minus 3. And I'm going to plug that into f. And f is x squared minus 4. So I'm just going to go ahead and plug in 2x over x minus 3. And what this looks like is this gives me 2x over x minus 3 times 2x over x minus 3, okay, minus 4. So let's do some simplification here. Multiplying fractions, you just multiply straight across. I get 4x squared over x squared minus 6x plus 9. And then I have a minus 4 over here. Okay. And let's see, man, do they want us to find a common denominator in order to, no, my notes say to stop here. But you could go ahead and do 4x squared over x squared minus 6x plus 9. You could go ahead and multiply top and bottom by that denominator to get a common denominator if you really wanted to. And then you could distribute that and then combine those. Do we want to do that? Do we want to take it that far? Let's go ahead and see what that would look like. Not too bad if you distribute this negative 4 into this trinomial. We get negative 4x squared plus a 24x minus a 36. These negative 4x's, or these 4x's here, they cancel out. This is 4x squared and negative 4x squared. And so this would be, I think, fully simplified, but my notes say to stop here. So, okay, here's a practice problem. Please go ahead, pause me, try this one. I'll show you the solution here in a second. Okay. If we go ahead and embed g of x into f, you get 2 times x plus 5 over x squared. I'm going to square this to give us x squared plus 10x plus 25 over x squared times 2. This 2, couple of algebraic misconceptions here, this 2 is just going to multiply into the numerator. So I get 2x squared plus 20x plus 50 over x squared, okay? Another misconception is that students will often just try to cancel these x squareds, but all of these terms are being divided by x squared, so you cannot do that. That would be incorrect to say that this is equal to 2 plus 20x plus 50. That would be wrong, okay? So right there is where you would stop. All right, last type of questions that we're going to see involve different forms. And the first example here says the table above gives values for the function g for selected values of x. The function f is given by f of x equals x squared minus 3x. What is the value of f of g of negative 1? So again, I'm going to go ahead and I'm going to take f of g of negative 1, and I need to find g of negative 1 first. So I have my table. So I go to my table, negative 1, g gives us 2. So this is f of 2. And now I use f. Well, f is this function, x squared minus 3x. So I'm just going to drop in 2 for x. So we get 2 squared minus 3 times 2, which gives us negative 2, right? 4 minus 6. Okay? Not too bad, not too shabby. Okay, here's a practice problem. Please pause me. I want you to try this practice problem here. Okay, here is the solution. You should have gotten negative 30. If you go ahead and you plug in 2 into g, you get the output 5, and then so we calculate f of 5, and when we get that, you get negative 2 times 25, so negative 50, plus 4 times 5, which is 20, so negative 30. All right. Hey, the last couple of examples are going to be calculator active, so I'm going to use calculator here or graphing technology. I'll show you 2 ways. I'll show you with Desmos, and I'll also show you with the TI Inspire. And so they say here, the figure shows the graph of the function f for a portion of its domain. The function g is given by g of x equals 0.16x cubed plus 2.09x squared minus 52x plus 139. The function h is defined as h of x equals g of f of x. Find the value of h of 3 as a decimal approximation or indicate that it's not defined. So what I'm going to do is I'm going to take h of 3 and I'm going to plug it in. So g of f of 3. And so I'm going to go to f first. So I use my graph first. So f of 3. Well, if I look at 3, which is right here, and I go up to my graph, I get 5. So g of 5. Now, if you don't have graphing software, if you just have a regular calculator, what you're doing here is you're just plugging in 5, right, into this function. And this gets kind of tedious, or this would be, honestly, a pain in the neck to go ahead and plug into a calculator. Not impossible. You could plug this into like a TI-30, right, or use this. But with graphing software, it's so much easier. I'm going to go ahead and I'm going to open up Desmos, and like magic, I have already graphed the function. So here is my function graphed. And what I'm going to do, now that I have it graphed, or entered, defined in Desmos, is I'm just going to ask Desmos, hey, Desmos, what's g of 5? And guess what? It tells you right away, negative 48.75. If I had more decimals, I would use more decimals, okay? But it's only 2 decimals. So you have to use at least 3 decimals, okay? So whenever they say decimal approximation, it's a good tip that you're using a calculator. Okay, please pause me. I want you to go ahead and try this practice problem here. See what you get. Okay, here is what you should have got. You should have got 309.49. That should be a 9. Again, how we get this is we plug in -1 into f, and if we plug in -1 into f, we get an output of -3. So g of -3, and then we go ahead and we just ask Desmos, hey, Desmos, what is g of -3? And you get 309.49. Hopefully you got that. Pretty straightforward. Okay, let's go ahead and let's look at another example, but this time not involving a graph. They give us information in a table. They say let f be an increasing function defined for x is greater than or equal to 0. The table gives values of f of x for selected values at x. The function g is given by g of x equals 3x squared minus 12x plus 25 divided by x plus 4. They say the function h is defined as h of x equals g of f of x. Find the value h of 1 as a decimal approximation or indicate that it is not defined. So again, I need to plug in 1 into my function, g of f of 1, and I'm using f first. So I go to my table and I find 1. The output is -8. So I need to find g of -8. You're going to have to do 2 things. You're going to have to define the function. So again, this is using a TI Inspire. I always tell my students, go ahead and graph the function. Whenever you have to define a function, just graph it, because then you could solve via graphing, or you can use it as a calculator. It's stored in your function. So I'm going to enter this function, 3x squared minus 12x plus 25 plus 25 in the numerator divided by x plus 4. So I'll hit enter. It will graph it, and then now I can go ahead and hit Control Doc to add a calculator page, and then I can ask my calculator, hey, what is f1 of, and I want this value evaluated at -8. So I hit enter, and I get -313/4. They want it as a decimal approximation, so make sure you hit Control Enter to get an approximation, -78.25. Okay? All right. So, and now that you have that stored, go ahead, please practice doing this practice problem. Again, if you're using Desmos, if you want to keep using Desmos, fine by me. That's free on the AP Precalculus test. It's a component built in. So, by all means, use Desmos if you don't have a TI Inspire. Okay, so pause me, try this one. Okay, and here is what I got. I gotta plug in my computer. I got h of 4 is g of f of 4. F of 4 returns 21, and then so we go ahead and go back to our calculator. We already have it defined, so I find the function evaluated at 21. I did have to approximate it. It's giving me a fraction, so I got 43.84. There it is. Hey, that is how you do composition. Moral of the story, you start on the inside and you evaluate that function, and then you plug that answer into the outside. If you learned something, give this video a thumbs up. I'll catch you in the next video. See you guys later.